Right, okay, so the breadth mock part 2, go through the extended questions with you. So question 21, complete the equation. This is base, it's a neutralization reaction. Base plus acid, salt plus water. So copper 2 oxide is acting as a base here. Complete that equation and balance it. Yeah, they're called hydrated salts. The substances that have water crystallization in them. So some of you got confused there. Some of you said hydrous, which is incorrect, and some of you said anhydrous, which is obviously the complete opposite. That's when there is no water present. Calculation of water crystallization seemed to throw some of you here. If you're given a percentage like this that's telling you that the anhydrous salt, 63.95%, then the other percentage, the 36.05, must be the water. Okay, so we take percentage by mass, so divide it by our molar mass, or relative molecular mass, which will give us the number of moles of each, the anhydrous salt and the water, and then we divide the smallest number into the bigger number, and that gives us the ratio. So it's 1 to 5. Okay. So x in this case is 5. So you need to practice this if you got this wrong. Really, it's a very straightforward calculation. You just think it through what's actually going on. It's just basically the ratio of water to the anhydrous salt. Copper sulfate contains ionic bonding. This is a definition, and some of you didn't get it right, and it's really irritating because I've told you time and time again to learn these definitions right from the beginning of the year. Okay, so yeah, it's only 1 mark, but that 1 mark could be the grade that you want. Okay, why does copper sulfate conduct electricity? You have to talk about the ions, not electrons, and there are no free electrons in an ionic substance. Think about it. The electrons have been transferred, so there are no electrons, and those of you who said electrons, I am not happy because I've stressed this as well. But you also have to point out that they are free to move, or they're mobile or something. Okay, but don't mention electrons, please, when you're talking about ionic substances conducting electricity. Oxidation number of copper in CuSO4. So, of course, learning your charges on your ions, very important. If you know that SO4 is -2, then you know that copper must be +2. Yeah, it's going to, obviously you can go through the process of working it out. It's not that easy actually to work it out because you don't know the oxidation state of sulfur either. We know that oxygen is always -2, so you need to know that SO4, the ion SO4, has a -2 charge, and therefore your copper must have a +2 oxidation state. The block in the periodic table that copper belongs to is the D block, not the transition metals. That is not a block, is it? Okay, and the D block refers to the highest energy electrons. Are they in D orbitals, P orbitals, or S orbitals? That is such an easy thing to learn. The periodic table, the blocks on the periodic table, please look at your periodic table again and make sure you know which is which. This is asking about calcium and tells you it's a group 2 metal, which if it's group 2 means it must be S, an S block. So when you write this electron configuration, you should recognize that at the end you should have S orbitals. Yeah, if you haven't, then you've not done it correctly. Calcium reacts with dilute hydrochloric acid. Only write the equation. This is a metal plus an acid. You should know this reaction. Again, it's very straightforward. You always get a salt plus hydrogen. But of course, you need to recognize that calcium forms 2+. So we need to chlorides to go with our calcium ion, and a number of you got that wrong, and then you need to balance that. Very put out that a lot of you represented this as a covalent compound. I mean, please, metal and non-metal ionic compound. Yeah, you could either show the electrons here, all 8, or not. Okay, but you had to put it in square brackets, and you had to put the charges in, and you need to show that the 2 electrons that have come from calcium are different. So that's why it's dot and cross. You need to show dots and crosses. Okay, high melting point, why is that? Well, if you hadn't recognized that it was ionic bonding, there's no way you could get this right. But you need to mention that ionic bonding is present. It's a strong electrostatic attraction, and a lot of energy is needed to break up the ionic bonds. That's it. End of. Calcium burns in air to form calcium nitride. Now, this is probably something you've not come across before, so this is applying your knowledge. It says treatment of calcium nitride with water produces calcium hydroxide and the gas X. So you know that calcium hydroxide has been formed. Yeah. Suggest a formula for calcium nitride. Well, you're told that the formula for the nitride ion is 3-, calcium is 2+, so the formula must be Ca3N2, and then you just have to look to see what else is left, what gas could be produced, and really your only option is nitrogen and hydrogen here forming ammonia. Okay, a couple of you got that right, but not many. Process of elimination. Okay, given an equation here, you're told that you have 0.8 grams of calcium and you have excess water, and you're just asked to calculate number of moles of calcium, which is very straightforward, mass over molar mass. And maybe I was quite generous with the marking. I'm not sure that you would get a mark if you'd recorded your answer to 5 decimal places, 1, 2, 3, 4, 5, yeah, because here obviously this is 3 significant figures, this is 2, so really you should have been recording it to 2 significant figures. So I was very generous, and same here really. Some of you left the answer like this, and that's obviously not appropriate, because you have to look at the numbers that you're working with, and you give your answer basically to the lowest number of significant figures or decimal places, however you're doing it. So you're looking for the mass of calcium hydroxide that could be obtained. Obviously, the ratio of calcium to calcium hydroxide is 1:1. If you look at this formula, there's 1 mole of calcium for every 1 mole of calcium hydroxide. So therefore, we've worked out the moles of calcium up here, so it's a straightforward relationship. So to work out the mass, obviously it's number of moles times molar mass, and there we are. Again, this is to 2 significant figures. Suggested value for the pH has got to be somewhere between 8 and 11 because it's basic. Okay, considering changes in oxidation numbers of the elements, you need to clearly show what is the change in oxidation number and which one has been oxidized and which one has been reduced. And the easiest way to do it is to do it like this. If you want to write it out, that's fine. But your 3 marks come from the fact that you're showing what's been oxidized, what's been reduced, and what is the change in oxidation state. So calcium goes from 0 to +2, hydrogen goes from +1 to 0. That's your 3 marks. Okay, this is group 4 element. The group 4 is the only group that has giant covalent structure in it. Please, you know, this is such basic stuff. Learn as you go across the period, where does the bonding change? You've got metallic, you've got the one group 4, that has giant covalent, and then after that we go for simple molecular. Okay, 1 mark, so they're not expecting too much. Okay, silicon can be made to react with chlorine to form silicon for chloride. It's given which has a melting point below and a boiling point above room temperature. So that's telling you that this will be a liquid under standard conditions. And I don't think anybody, or maybe one person, put the state as a liquid. So you can only get 1 mark. If you balance the equation, that's fine. And you've got your solid and gas here, which most of you did. But I think only one person put this as a liquid. Use the information in the question, please. Okay, that's what it's there for. Again, it's telling you that it's made of simple molecules and asking you to explain the shape. So this will be tetrahedral because it's a central atom surrounded by 4 other atoms. Yeah, we've got 4 covalent bonds, i.e. electron pairs, and they all repel equally. And that is a standard answer for explaining the shape of a molecule, of a bond angle. Sorry, it's because of repulsion. Repulsion is equal. Okay. They're non-polar. Okay, so the molecules are non-polar, but the bonds will be polar. Yeah, but because it's symmetrical, obviously the individual dipoles cancel each other out. That's your answer. So here you're actually asked to explain what London forces are. How do they arise? So you need to use the terminology that is, related to London forces. So you get an instantaneous or a temporary dipole occurs in a molecule because of, movement of electrons or uneven electron distribution, however you say it. But the instantaneous dipole is created first. This induces a dipole in a neighbouring molecule, and then there is an attraction between them. And there you go. A number of you didn't. Well, I don't know whether you still don't understand how London forces arise. I don't know. If you don't, you certainly haven't discussed it with me. So maybe that's what you should be doing if there's something you still don't understand. Oh, it looks like I've missed out something on this equation here. Okay, so you're asked to write an ionic equation, yeah, for when you add chlorine to sodium bromide. So ionic equation means just the ion. So here I should have put Br2 Br minus. Yeah, sorry about that. So Cl2 plus 2 Br minus forms Br2 plus 2 Cl minus. Yeah, so this is displacement of the halides. But it's ionic equation, so not the full equation. How should the student have tried to show that bromine had formed in the reaction between chlorine and sodium bromide? So the bromine, obviously this is in water. Yeah, you would generally add your chlorine, would be in chlorine water. You wouldn't add chlorine gas. So if you add cyclohexane to this, and I did discuss this with some of you when we did this practical, that the bromine will dissolve in cyclohexane much easier than it dissolves in water. So when you shake it with cyclohexane, you would find a layer above the water layer that would be orange. Okay, the student then added a solution of chlorine to sodium iodide solution. What other experiments should the student have performed to obtain the relative reactivity of all 3 halogens, chlorine, bromine and iodine? So basically, so you've done the chlorine and sodium iodide, you would get a displacement there, but you also needed to show that if you added bromine to sodium iodide, you would also get a displacement, and that will then give you the 3 halogens, yeah, and their order of reactivity. Okay, this question, state and explain, and it's 5 marks. The trend is in reactivity of the halogens as the group is descended, so as you go down the group. So some of you didn't state the trend, you know, that's your first mark. The trend is that the halogens get less reactive as you go down the group. Yeah, and then obviously the question is why? Because they need to attract an electron. So you have to think what makes it harder for them to attract an electron as you go down the group. The atomic radius increases, electron shielding increases, so therefore there is less attraction from the nucleus because of these 2 points that we've said here. So they are not going to be able to attract electrons as easily. They're going to be less reactive as you go down the group. And some of you confused your answers, you know, from this question to this question. Explain why the boiling points of the halogens increase down the group. Yeah. So ask yourself the question, you know, what is the important factor here? And it's London forces. So why, you know, do the London forces increase as you go down the group? It's because the atoms are getting bigger and there are more electrons present, and this leads to the larger instantaneous stroke-induced dipoles, which lead to stronger London forces. Yeah, and finally, so you're going to need more energy to break those London forces, and that's why the boiling points increase. And then finally, this last question, what do we use sodium chlorate for? It's bleach. And of course, in this reaction, chlorine has been both oxidized and reduced. So this is a disproportionation reaction. End of paper. Okay, so that's the last bit of the breadth mock. Bye.